Again, so an El Nino year is when, for some reason, the trade wind stops, so the hot water doesn't go to Indo, it stays in the middle. Because it stays in the middle, there's more moisture on our side, less than normal on their side. So we end up getting flooding and extreme rains and northerly storms and really big surf. They end up getting colder than average, drier than average, less monsoonal precipitation. It affects their agriculture negatively. And I've got to introduce to you a new term. I'm not sure the College Board knows this yet. But in 2009, scientists in Japan introduced a new word to the El Nino southerly oscillation. It's modoki or modoki. I guess Japanese doesn't have discrete accents, so I don't know how to make that sound right. Okay, I'll go with that. Thank you, very helpful. Modoki. Are you kidding? You really do?
No, I think it's
awesome. Say it again?
modoki.
Okay. And it means neither here nor there. It's kind of like when something's in between? Yeah. That's exactly the point. In Japanese, modoki means something that's kind of halfway, in between. It starts like an El Nino year, and then halfway through, the wind starts. It's like a psych out. So we get some El Nino conditions early in the year, but then it's back to normal by the end of the year. There's a new term. It's a Japanese word because Japanese scientists were the first to notice it. You can imagine Japan really cares because this affects their fisheries. Japan is very closely tied to the ocean. So Japanese scientists were the first to measure this. They said, wait, 2009 started El Nino, finished without El Nino. This is an in-between year, a modoki year. Yeah.
What is that word saying about drier?
Relatively.
Okay.
Meaning relative to their usual weather, it's less rain. Can we what? It's really easy to predict when it's already started. It's like everything else, you can really see it when it's closer. So far out, the question is how far can we predict them? We start beating a coin toss at about 6 months. We beat 75% at about 2 months. And we can still be 10% wrong 2 weeks away from the beginning of the season. As a matter of fact, you can start as an El Nino year. You're like, this is clearly El Nino, but it won't even finish as an El Nino because of the modoki potential. This is a fickle and strange cycle. There is one thing you should know, though. El Nino years increase global warming. We're not sure that global warming causes El Ninos. People have suggested this, but it's a mystery because we don't know what causes El Ninos. So maybe global warming makes them more common, but we can definitely say the opposite, that El Ninos increase global warming, because please look up, some part of the ocean is cold here, so you've got a lot of algae. The ocean is hotter on the surface here, so you get less algae, so there's more CO2 left in the air during an El Nino year. Does that make sense? El Ninos increase global warming because they leave CO2 because the ocean is too hot. Yeah.
Is that just like in the middle of the ocean and like north and south there's still the westerly trade winds going on?
Well,
there be some up there, just like less in the equatorial area? Or is it affect like the whole ocean?
The effect is strongest at the equator, but it influences the whole ocean because don't forget, this pattern is still there, stronger or weaker. So now, if you're putting all the moisture in this part, that's a long way to travel to reach Santa Barbara. But if all the moisture is kind of in the middle, then some of these shears are going to bring that moisture closer to our side. So there are secondary impacts on the other circles and other currents. The main obvious difference is where the hot water is. And I'll show you a photograph. Hold on. You can see an El Nino here. La Nina is normal. El Nino has that big streak of hot in the wrong place. So they get a drought, and we get to keep all the heat, which means we're keeping all the water. And we get to keep all the heat, which means we're keeping all the water vapor. Does that make sense to everyone?
So make your oceans warm?
Yeah. This is ocean temperature.
I know, I'll be like California.
Yeah, you can kind of see that by the time you get to California, the effect is kind of more subtle. But I think you can see that difference, right? At the top, all that red and yellow, compared to here.
Sweet.
Oh, there's like a lot of red right by Southern California too, compared to the rest of orange.
Yeah, right, because this affects the strength of the current and how much cold we suck out of Alaska.
What's the how much temperature is actually changing on there? Like, what is the red versus?
I'll bet you this is a pretty subtle difference. It's got to be
within degrees.
A couple degrees.
Like,
yeah, sorry.
The algae life
I believe so.
Really?
That's why
Well, colder temperature holds more oxygen, but algae eats CO2, so I'm not sure why there's an influence. I'll bet you that colder water also holds more CO2. Because everything dissolves into water more. It holds more nutrients in general, not just oxygen. Things dissolve better in colder water because the water's more still. There's better spaces for stuff to fit.
Also, there's probably like
well, yeah, upwelling. So the water's more nutrient rich from the upwelling. Yeah, that might be it.
I just don't understand why El Nino's affect global warming.
Because remember that algae is a regulating force to global warming, right? Algae eats the CO2 that's heating the planet. And if you had less algae, you'd have more CO2, right?
Yeah.
Okay. This kills algae. Why? Because this encourages algae growth. Nutrients in the water and dissolve.
Oh, the upwelling stops.
Right. Okay. So in a hotter ocean, you have less algae activity. Which is kind of the opposite of what I said earlier. Hotter ocean encourages. No, the CO2 encourages the algae.
So there's more algae in a hotter area.
Yeah, I mean, I'm confused by this too. I can talk myself into a circle, so I'll stop.
I mean, yeah.
Yeah, let's assume that it's more than dissolved nutrients and temperature.
There's no current.
Yeah, so maybe it's less mixing of the water. Cool. All right. Number 24 is the most depressing study goal of the year. Let me try that once more. Number 24 is the most depressing study goal of the year because number 24 is a survey of research about what will happen when the climate changes. Now, your book had a fine list, but I have 11 research papers to tell you about. Remember, we know a lot of variables in the climate equation. And there are nerds who study specific parts of that climate equation. Ian might focus on how rainfall patterns affect vegetation growth. Tyler might focus on how diversity responds to changes in precipitation. I don't know. The point is that if you want to go get a PhD in climate science, you'll have to pick a part of the equation to focus on, and you'll write your doctorate about how climate change affects disease or water supply or agriculture or something. And I've been keeping track of these papers over the last 10 or 15 years. Your book had some pretty cool ones, but I have some really hard to dispute predictions. I'm going to give you 11 of them. And I need you to keep track because we're going to start on this list tomorrow. So keep track of the numbers, and remember that tomorrow's kind of an important day, so we'll have to be straight business, get back to this list wherever we leave off. Number 1 of 11. We can't be too sure about details, but we know global weather patterns will change. If you want to know specifics, you're kind of on your own. Really loosely, we can make a couple of statements. 0 and 60 will probably get wetter, 30 will probably get drier. In other words, this will exaggerate. This pattern will probably exaggerate. The wet areas will get wetter, the dry areas will get drier, but that's an average. So when you want to ask me about an individual place on the map, neither I nor many people could give you reliable predictions about weather. We know that it'll change. And you've already seen some of those details, like how the current changes. So Europe gets colder while India gets hotter, Europe gets drier while India gets wetter. It's like that. We're, climate trends, sure, we know are going to change. Weather patterns will shift. Kind of hard to say for sure how. Number 2 is something you've already heard about. In response to changing weather, species will move. Their range will change. But they won't necessarily move together. Remember that concept, ecosystem shear? The idea that the flower moves north, but the pollinator moves south, so they cannot survive because of their community-level interactions, not because of the temperature. This is a key distinction. Students say this wrong every time. So let me try to split the hair again. The changes in temperature, in rainfall, in wind, in stormy days are not on their own deadly. The butterfly can survive a degree hotter, and the flower can survive a degree hotter. But how do they respond? One goes this way, one goes that way. Now they no longer live together. You might remember when we talked about food webs, and we had a big piece of paper, and we drew a giant food web for the Sierra Nevada. And I told you, there are other layers of relationship, like habitat, who lives in the tree, or who lives in the leaves dropped by the tree. Now, if the tree range shifts one way, but the bug range shifts another way, you may no longer be pollinating the tree, so the trees stop spreading their seeds and they eventually die. Or the bug may not have the leaf litter to live in, so the bugs go extinct. And now without the bugs, the mice are more hungry. With less mice, the owls are impacted. Nobody cares about the temperature. It's not the climate killing stuff. It's how climate affects their community of other species that's killing stuff. Does that make sense? Ecosystem shear?
Yeah.
Yeah.
So like more specialized organisms, like things you eat more quickly than they can adapt. Like
not exactly. So your statement is probably also true. I think another way to say that would be that specialization gets harder because the variables are all responding. So if you rely on a very carefully timed pollinator to show up on March 15th, that pollinator might show up 2 weeks later because it's a little hotter in Mexico or whatever. And then your flowers have closed up and you don't get pollinated. You can't be that specialized anymore because the other parts of the equation are responding to their own climate issues. Okay, number 3. Agricultural zones become less productive. The funny thing is, whatever you specialize in, you can't grow it anymore. Either hotter or colder or whatever.